আমরা ফিল্টার ডিজাইন পড়েছি, filter design, IIR filter design, FIR filter design, all these things I have discussed. But the problem is uh, তুমি এগুলো পড়েছো কিনা, তুমি কি এগুলো ফিল্টার ডিজাইন এগুলো নিজে একবার দেখেছো? এগুলো কিন্তু খুব ইম্পর্টেন্ট, এগুলো কিন্তু মানে পরীক্ষায় আসবে। So basically today I will discuss about realization of FIR filters or IIR filters. After designing, how we can realize those filters in practical. Means what are the component, what are the things we have to use to implement these filters. Now since it is a digital filter, very obvious, we need some memory, that's it. And what are the basic mathematical operations we have to do? We have to do addition, then we have to do delay or shifting and accumulation, like that. So multiplication, addition, shifting, delay, these three mathematical operations we have to perform to realize a IIR or FIR filter. Now in this realization portion we have different structures available. That for IIR there are different structures: direct form 1, direct form, parallel structures are available, and realization. So one by one I will discuss those things. So now I will share a PDF. If you can see with this video, you please confirm me. Okay, so filter realization, can you see this PDF?
Yes, sir.
Hello, can you see this PDF, Pranay?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Yes, sir.
So
Hello.
basically, হ্যাঁ হ্যালো, শোনা যাচ্ছে তো? পিডিএফটা দেখতে পাচ্ছ? Okay. Now, so first of all, the first I will discuss about. No, I will not discuss about FIR. I will discuss about. First of all, I will discuss about IIR realization. This one. IIR FIR filter realization. Now, the first things I will discuss about which one is direct form 1, DF1 structure. Now, what is DF1? Now, this formula, it is a very well-known formula for a recursive. Consider an LTI recursive system described by the difference equation. Now, what is recursive? Recursive means there is a feedback. Meaning of recursive means there is a feedback. Feedback means from output to in general sense. What is the meaning of feedback? Feedback means if I ask for student feedback or teacher feedback, what is the meaning? That if the teacher delivers something, and if he or she is asking for a feedback, means that feedback should be come from student. So I am giving something, and with respect to that I am expecting some feedback. So that is the feedback system. In case of electronic system, feedback means feedback from the output, feedback from the output to input. I think you have an idea of what is feedback amplifier. You know what is feedback amplifier. Similarly, this digital system, the recursive system, means the system have a feedback from the output. Okay. So this mathematical equation, which is represented by y of n, is a standard representation of a recursive system, and this is a difference equation. Obviously, it is represented by summation, so it is a difference equation. Now, so y of n is equal to k1 to the power, k1 to capital N, a k y of n minus k. Here y is the output. Okay, remember that y is the output. Now see, the lower limit for k is 1. Why? Because I wrote yn here. If it starts from 0, if I put k equal to 0, it becomes y of n. So y of n I wrote in the right hand side, sorry, left hand side. So that is why this summation is starting not includes the value k equal to 0. It will start from k equal to 1. K equal to 0 is already written here, y of n. And this negative sign, that is why it is negative sign. So if I wrote this summation at the left hand side, then I will include this y of n. So then I can write down k equal to 0. But since I wrote it in the right hand side, so that is why k starts from 1. 1 to capital N, a k y of n minus k, plus then this x stands for the input. So k equal to 0 to m x of n minus k bk. Now here ak and bk is the coefficients. Okay, so here ak and bk is the coefficients. Now I'll just put the value of k 1, 2 up to n, and also value of k at the left hand side. Both. So we are expanding this summation. That's it. Okay. So after expanding this, I can write down. Now what we assume, let b0 x of n. So I take this total term, we consider as a w of n. Getting my point? We had considering this is
Yes,
the
sir.
y, w of n. Now,
Yeah.
if this term is w of n, so I can write down y of n is equal to minus a1 y of n minus 1 minus a2 y of n minus 2 dot dot up to a of n plus wn. So these are the two equations. I give the first one is equation number 1 and the second one is equation number 2. Okay. Now, now so
Mhm.
the equation number 1 and 2 can be realized. Now I am expressing this mathematical equation in the form of a structure. And this structure is called DF1 structure. Now to realize that if we notice, if we know sorry, if we just a minute, mm, if we notice that if x of n is the input, then x of n minus 1 is the delayed version of x of n by one sample, and x of n minus 2 is the delayed version. So delayed version. So what will be the value, next value, x of n minus 2? Similarly, so if we take x of n at the input, then if we provide a delay, this delay is represented by z to the power minus 1. Why I am saying this? Because if we take the z transform of x of I minus 1, x of n minus 1, it will be z to the power minus 1 x of z. So I am writing out this delay in terms of z transform. So that is why this block z to the power minus 1 means I am delaying x of n by one sample. Getting my point?
Yes,
So,
sir.
okay. So if the input is x of n, then it will be passed through this z minus 1, and what will be the value here? This is x of n minus 1. So after passing through z to the power minus 1, thus x of n is get delayed by one sample. Getting my point? Then it is multiplied by,
Yes, sir.
so x of n minus 1 is multiplied by which sample? What is the coefficient value? What is the coefficient value, Pranay? Can you tell what is the coefficient
Yes,
value
sir.
is multiplied? With the n minus 1, what I have multiplied here? B1?
Uh,
Okay. So that is why this x1 passed through the B1. The pass through means B1 means when the x of n minus 1 passes through this line, it will be multiplied by B1. Getting my point?
yes, sir.
Similarly, first term is multiplied by which value? Can you tell me?
X, XN.
X of n is multiplied by which value? Which coefficient?
B0, B0.
B0. Okay. So that is why see
Yes,
x of
sir.
n just goes to B0, and at the output I am getting B0 into x of n. Here I am getting B1 into x of n minus 1. Okay. So what will be the next term? What will the next term? It will be, so it will go, so this one is what? This is x of n minus 2 because it is delayed two times. One by here, another by here. So what is the signal
Mm.
at this point? Just a minute, I'll take the pen over here. Comment, yes. So what is the signal at this point? The signal, wait. Okay, so signal at this point, I am asking about what is the signal value at this point. That means, see, x of n is delayed by one sample here, and x of n is delayed by another value. So what is the point here? What is the value? The value of x is x of n minus 2.
1, 2.
Okay, because the x of n, passing through two delay. So so this block, this z to the power minus 1 block is it will delaying your sample by one value. Okay, then this is the multiplication. So total block this total block, if you consider, this is the equation number 1. Can you see? So I am getting this value, then getting this value, then getting this value, and I can add all of this. So this is the summation. I can add all of this, and that is equal to your W of n. So this is the left hand side of this image or the figure is basically equation number 1. Equation number 1 means I am talking about this. ঠিক আছে, বুঝতে পারছো?
Yes, sir. Yes. Ha,
হ্যাঁ,
ha.
so basically, so this is the value of UW of n. Now what is the output equation? No, sorry, what is the equation number 2? Equation number 2 is y of n is equal to this equation plus wn. So that is why I take the wn and pass through this summation. So wn is summed over here. Then see, then I have taken a feedback from the output. So this is the feedback from the output, and I am delaying y of n by one sample here. So this what is the output over here? This is the y of n minus 1. What is the output over here? This is of y of n minus 2. Okay. So again, this y of n minus 1 is multiplied by minus a1. See, the coefficient is minus a1. What is the coefficient over here? What is the coefficient for y of n minus? What is the coefficient of y n minus 2? Pranay, can you hear me?
A2.
Not a2, it is minus a2.
A2.
Minus a2. No, minus a2. ঠিক আছে? So coefficient is the minus a2. So basically, so this equation number 2 is this one. The total block is basically realizing the equation number 2. So finally, if we erase all this, just a minute. So this is this total block. This is the DF1 realization. So this is the DF1 realization. Getting my point? This is the DF1. See, the output is y of n. The output is y of n. So y of n is equal to Wn plus this value. Wn plus this value. So this is called direct from 1 realization. Now after designing IIR filter using any method, either bilinear transformation or impulse invariance technique, you can represent your x of z to either df1 or df2 or cascade or parallel, whatever it is. Then we can realize in a structure wise. So that mathematically or at the memory element we can realize these filters. Okay. So this is the DF1 realization. To realize a IIR filter in DF1, we need how many multiplications? M plus n plus 1 multiplication, M plus 1 addition, and at memory location. So this is the ultimate thing. This is the ultimate thing. How many multiplications I do? M plus n plus 1 number of multiplication, M plus n addition, and at and M plus n plus 1 memory locations. Okay, so this is the called direct from one realization. Now what is DF2 realization? Second one is uh, I will say about, I will describe what is direct from two realization. Okay, so far any confusion? আশা করি বুঝতে পারছো আর যেগুলো এগুলো বলা হচ্ছে। Okay, okay. So what is DF2 realization? Now in DF2, what we do basically, this is the standard difference equation. Y of n is equal to minus k 1 to n ak y of n minus k plus k equal to 0 to m bk x of n minus k. So this equation I wrote just in DF1 also. So now what we do, now we are doing the z transform. What? We are writing h of z. H of z is what? Yz by x of z. So yz is basically this one, and x of z is basically this one. Okay. So how can I write down this? If we take z transform of the both side, then we can evaluate this value yz by x of z. Okay. So after doing that, what we have done, see, yz by wz into wz by xz. This wz will cancel out. So ultimately, this is y of z. But I wrote in this fashion. I represent h of z in this fashion: yz by wz into wz by x of z. Then, so what is that? If we compare this, then wz by x of z is this one. Okay, this is called wz by x of z, and yz by wz is this one. So if we compare these two equations, if we compare this, so it is easily understandable that what is we have written. Now we just multiply. Now we just multiply and expand this summation. If we do that, so for this, I'll get this equation, and for the second, for this, I'll get this equation. Okay, so this is the two equations I received. Now I will realize. Now I will realize two equations. So first of all is, what is x of z? Then we have wz to the power z. So wz is delayed. See, wz is delayed here. So that is why I take wz and it will be delayed. Okay. So what is that? This is wz of. Oh, okay. Okay, you have lab after 3:45. Okay, so Ritam sir will take the lab, I think. তুমি কি জানো যে অনলাইনে ল্যাবের ক্লাস স্টার্ট হয়েছে? তুমি কি আজকে প্রথম ক্লাস করছো প্রণয়? হ্যালো, আচ্ছা আচ্ছা, তোমাকে বলে দিই যে ল্যাবের ক্লাসও কিন্তু অনলাইনে স্টার্ট হয়েছে। ঠিক আছে, এই 5 মিনিট বাদে আছে, আমি দ্রুত এটা শেষ করে দিয়ে তোমাকে, ঠিক আছে, রিতম স্যার ক্লাসে জয়েন করো কিন্তু, ঠিক আছে? আচ্ছা, তাহলে আমি এটা কি করছি দেখো, কুইকলি দেখে নাও। এই wz-টা হচ্ছে ডিলে হচ্ছে। দেখো দুটো ইকুয়েশনে আমি যদি দেখি, তাহলে wz-টাই কিন্তু দেখো এখানে একটা ডিলে হয়েছে, এখানে দুটো ডিলে হয়েছে। এই z টু দি পাওয়ার -2 মানেই কিন্তু ডিলে ইন টার্মস অফ z ট্রান্সফর্ম। এখানে কত ডিলে হয়েছে? n স্যাম্পলস। এখানে কত ডিলে হয়েছে? m স্যাম্পলস। তাহলে আমি wz-টাকে আমি সেন্টারে রেখে আমি যদি দুদিকে স্ট্রেচ করি, তাহলে দেখো আমি এদিকের কোএফিসিয়েন্ট গুলো রাখছি a1 a2 an, আর এদিকের কোএফিসিয়েন্ট গুলো b1 b2 bn। আমি তাহলে পুরো সিস্টেমটাকে রিয়েলাইজ করতে পারছি। দিস ইজ কল্ড DF2 রিয়েলাইজেশন। এবার DF2 রিয়েলাইজেশনে দেখো তফাৎটা কি, এখানে আমার মাল্টিপ্লিকেশন সেম থাকছে, অ্যাডিশন সেম থাকছে, কিন্তু মেমোরি লোকেশনটা কমে যাচ্ছে।
হ্যাঁ
দিস ইজ দ্য অ্যাডভান্টেজ অফ DF2। তার মানে আমি যদি কোনো ফিল্টারকে DF2 তে রিয়েলাইজ করতে পারি, তাহলে আমাকে সেখানে ডিজিটাল কম্পিউটারে যদি স্টোর করতে হয় বা ওই স্ট্রাকচারটাকে ফিল্টারটাকে রিয়েলাইজ করতে হয়, তাহলে এটা কম মেমোরি লাগাবে। মেমোরি লোকেশন ইজ লেস ইন কেস অফ DF2 রিয়েলাইজেশন। ঠিক আছে? হ্যালো?
হ্যাঁ
হ্যাঁ,
বুঝতে
আচ্ছা। তো এইটা হচ্ছে একটা
বুঝতে
শর্ট
পেরেছি।
ডিসকাশন করলাম DF1 DF2। আমাদের বৃহস্পতিবারে আমার ফার্স্ট ক্লাস আছে, ওখানেও আমি এটা আবার আমি আবার কন্টিনিউ করব। আপাতত ডিএসপিটা একটু আমি এগিয়ে দিই, কেন অনেকটা পিছিয়ে মানে
হুম,
আর্কিটেকচারটার নোটস দিলে হয়ে যাবে, কিন্তু ডিএসপিটা আমাকে ডিসকাস করে করে করতে হবে। ঠিক আছে? দাঁড়াও।
আচ্ছা আচ্ছা, হ্যাঁ ঠিক আছে।